Okay, I guess we are recording now. Okay. Welcome, Shaleen. Welcome to our 14th episode on machine learning for beginners. And it's really great to have you because I guess we share the same college we did our undergrads from. So I have been knowing you since for a while, and I have been following your work for quite a while. And I know you have been working on applications of deep learning. And it's really great to have you over here for this episodes. And for all those people, before we move on to Shaleen, for all those people who are over here for the first time on this channel, I create these videos and by inviting people who have been working in the domain of research of machine learning for quite a while. And the idea is to gather their insights and help the new students who are trying to break into this machine learning domain to help them get better insights, how to get started, and what are the do's and don'ts typically from people who have been working in this domain. So before I move on to Shaleen, just a quick intro of me. I'm a PhD student at Arizona State University, working at the cross sections of applications of deep learning for healthcare domains. And I'll move on to Shaleen over here. So Shaleen, can you tell us just a few words about your background?
Sure.
And what is your current work? What are you currently working on over here?
Sure. Hi, Jay. So, and hello everyone else as well. So, always happy to be connected with you, Jay. I've been seeing your videos on YouTube, and they're quite good for beginners to like understand what the end goal could be, or so nothing is the end, of course, but then like what they could aspire to become, or maybe like go beyond. So that's something really nice, and I've been following you on social media as well, where you talk about your thesis and stuff. So yeah, happy to be invited. So yeah, as you rightly mentioned, I am Shaleen, and I am a software engineer in Google, where I'm working in a team called Magma/Deep Magma, where we work on mostly semi-structured ranking of semi-structured documents and semi-structured queries. And to like make our ranking and search quality overall better, we often employ deep models and sometimes statistical models as well, and other kinds of things which from like classical IR, which help us improve ranking overall. So yeah, that would be a quick recap of me. Before Google, I was at Carnegie Mellon University, where I was doing my master's in this department called Language Technologies Institute. So my department basically deals with the NLP problems and employs machine and deep learning often to solve these problems. So yeah, that's pretty much about me.
Right, right. And I also know because back in our undergrads, I guess one thing that we also have a common is we have kind of a research experience working at NTU and all those things. So like
Right.
the reason I bring that up is like what was the point that was your outburst to this domain of machine learning? Because I'm sure pretty much, I mean,
Of course.
undergrad is normally a time people carve out their interests. So
Mhm.
what was the moment that made you decide that, hey, machine learning is something I want to do, like that some secret thing that really excited you, and how
Right.
did you take it forward from there?
So that is actually a very interesting question that you bring up. So I have not actually thought about it very objectively, but there are a bunch of things that eventually led me into this field. So I think one of the first interactions with AI that I had was through this startup that I was a founding member of. This was a startup started by one of the professors at the Rubai Institute. It was Rigby, which is now called Ragster, now that it's live. So it was a search engine that would allow a better semantic search for research papers. So that it would be a complete suite for any researcher to kind of find related papers on a particular topic and basically do their entire research on it. So I was basically a newbie into this field because I was only, I think, 1 year old in computer science officially, because it was the second year of undergrad. So I think that was the first time I was introduced to NLP as a proper computer science discipline field per se. And in that field, we often like used a lot of machine learning tools. Of course, at that time, we were not it was not a very hotly talked about field, and also because I was not very good at using search engines to my best use. So, people were, of course, using deep learning and machine learning for NLP tasks, but at that time we were mostly relying on, there were other kinds of rule-based algorithms and dynamic programming algorithms that would help us build natural language systems. For example, I was working on this thing called co-reference resolution, which is basically identifying which noun is particularly tagged to every pronoun. And we used to use these algorithms called Smith-Waterman algorithm and other things for like sentence simplification and other kind of tasks. So after that, like when we kind of progressed more into the startup, we realized that, okay, maybe using machine learning to do these things would greatly simplify things and make things more accurate. So which is when I started like doing some online courses. Of course, it starts for many people with the classic Andrew Ng's course on Coursera. But then there are other courses that I did. One was this deep learning specialization nano degree or something it's called,
Yeah.
which is a degree certificate course. It's a suite of 4 courses that they offer on Coursera. Around that time, I started attending lectures of Professor Prasenjit Majumdar's information retrieval course and some of Sauridas Gupta's AI course. Then, of course, eventually I found myself at the Computational Intelligence Lab, just like you, at NTU, Nanyang Technological University in Singapore, where I was like formally now using neural networks as opposed to the statistical machine learning tools that I was using earlier. So that kind of like developed a stronger interest. And so these are basically two, one separate story and the other story that starts from my rural internship. So rural internship at DAIICT is basically this, for people who don't know, it's basically a period that every every engineer that graduates out of DAIICT has to spend. So it's like about a month or so where they work with an NGO and most typically in a remote village. So to like really understand from the inside what the challenges that are that the society faces currently. So I was at this village which was in at the where Gujarat, Madhya Pradesh, and Rajasthan meet. So it was at this this village called Limkheda, and I saw that a lot of people were using mobile phones, but they were not very comfortable using everything in English. So people were using mobile phones because they could like type on it. They could like call people on it, but still they were not able to leverage the amount of power that a mobile phone, something as simple as a mobile phone even, and even the other things like laptops or computers, they had everything, but they couldn't really use that power. And one major thing was that was the language. And it's a very well-known field that people are now working on. It's called low resource languages, where they're trying to make things more accessible in languages, also other than English, yes, but also in languages which have very limited training data available. So that was something that eventually like I connected with during my internship at CMU, at NTU. And that kind of like gave me some motivation into go into NLP to maybe work on internationalization, and not just internationalization, but also low resource languages and things like that. So that's how I eventually got induced. And I think I did a formal like training on neural networks and maybe the advanced concepts in neural networks and other machine learning concepts when I was doing my master's, where I could take courses. I was fortunate enough to take some of the courses offered by the authors of many great papers. So that's something that I really like value, as I'm sure many courses, many institutes in around the world offer. So yeah, that's about it. That's how I got into this field.
Yeah, yeah. I mean, that's a very nice perspective, because if I were to like kind of see kind of a bird view on this whole journey of yours, like you have at least like you have kind of an academic background versus you have also tried your hands on to a startup, as you mentioned, at DIICT, and progress to that NTU, which is kind of a higher research institute. And then over the time you have also worked, like of course Google is of course like the biggest thing in this particular whole bird view that I can say. But if you were to kind of distinguish between how research or how these tools like machine learning in general is being used at industry settings versus like, let's say, CMU, NTU, or in general DIICT? Like, do you see a distinguishing between factor between them? Because you're now working at Google, which is kind of a leader in this domain. So like how they are seeing deep learning, like they might have a revenue perspective to it, definitely, but what is the use from a student perspective as a person? Like, what differences can I expect or should I expect, like if I'm a person? Because right now when I'm working over here, like the goal is to just solve a problem. They don't care about the scalability or the accuracy values, but the idea is to
Correct.
just kind of just do a prototypical thing over here. So
Right.
in terms of a much more granular detail, if you can provide, of course, feel free to just hide out the information that is really
Sure.
confidential over here.
Not a
But
problem.
like, if you were to distinguish between the use of these or the view of people handling these technologies, how would you distinguish them?
So that's actually a very interesting question again. So oftentimes people like try to compare them by saying one versus the other, one is better, one is worse. I wouldn't exactly think of it that way. I would say that like by the virtue of it, it like aids one another. Industry is where the problem stems from. Not the problem actually exists in the society. Industry is basically some person who decides that, okay, I need to like of course solve this problem, but also there is sometimes often a secondary motive of making revenue out of it. And then on the other hand, research is where like people are like trying to solve the problem from a more holistic perspective. They are many times not concerned about the scalability and how that will go in production and how that will become a product that people can actually use, but focus more on how they can push the frontiers furthermore so that other people can probably go and use their research and maybe build products about with it, and then like make the lives of people in society better. So of course they aid one another, and oftentimes we see that papers that get published in the top conferences nowadays are often like each sometimes most papers are like a combination of authors from industry and academia. um, and there are two different sides to it. So industry typically has a very well-defined set of problem that they want to tackle at a given point. And second, they usually tend to have a lot of resources which they can shell out for that in terms of hardware, compute power, and other kinds of library support, and maybe support the intellectual support from other engineers in that industry. Uh, on the academic side, they bring along, they have professors which have been working on similar problems for a long period of time. So they are usually well read and well caught up on what kind of things might work and what might not work. So, and even professors, they keep like switching sometimes between industry and academia. So it's kind of a fluid system. Now coming to your question, where if you talk about it from a student's perspective, so few things that I've noticed in an academic setting is that there is often like the focus is on getting results uh, uh, and comparing them with different kinds of approaches. And for example, what I mean is that if you want to say, you take a particular problem and you figure out one method to solve it, you're also interested in different other ways to solve it. And then you kind of like publish like a comparative study, or you try to take up a paper, like a paper that has already been published, and consider that as your baseline. And then you try to beat their performance, and then you try to like publish those things. Uh, Oftentimes they are like constrained. Sometimes, for example, if you are say Google and they are a big corporation, and there are many other companies like that which have a lot of computing resources. So at least at NTU, sometimes we used to feel that because if your research is not like supported by an industry giant like that, there might arise a dearth of resources at some point. For example, if you want to use two TPUs, so nowadays most of the work in NLP is now focused around these special kind of neural networks called transformers, which are kind of very hot now. So these transformers need a lot of resources to get trained. So these are certain kinds of issues that you would face in an academic setting, but not so much in an industrial setting, because you are trying to like eventually make money out of it. And then so because you are going to make money out of it, you can spend, they have a lot of deep pockets to like take out money from oftentimes. Um, Another thing I noticed is that, of course, like you mentioned, it's about scalability, it's about productionizing, and you have to make things fast. You have to make things feasible. It can't be like very expensive when it runs in production. You can't have infinite amount of resources, so it has to be like fast enough and cheap enough to run. One major concept that also very greatly differs is data security and privacy. So because when you're operating in as a business and you are like using your letting consumers use your product and their data, the data privacy laws differ across the globe, but even as in general ethics, and most companies try to of course be as ethical as they can, and I'm sure some of them are doing quite like that is a very major concern for most of us as to what they're going to do with privacy. So that sometimes constrain your work, because as a machine learning engineer or as a deep learning engineer, you need data, and you need data to be really available in node earth. So that is not as big of a concern when you are doing it in an academic setting, because it's not, you are not really interested about the inference part of it, where it will be running live somewhere. Of course, there are many research projects which, of course, have something that goes live as gets formulated as a startup later on, but then they kind of try to worry about these privacy regulations and stuff later on when they think about it. Yeah, there's that. Yeah, if I think about anything else, yeah, I think that's pretty much what I would say the difference would be.
Yeah, I guess so. Like, if I understand this correctly, I mean, when you work in an industrial setting, there are much more layers to actually think about getting in
Mm-hmm.
a product. But in terms of, I guess, academic settings, the focus is much more on just getting results. I mean, just kind of making a point for a proof of concept. But when you
Yeah.
go to an industry settings, there are all these
Correct.
factors of
And many things
scalability.
differ because of these constraints. Sometimes that when you're in industry, you don't worry about these limitations, and which also like opens up your horizons of what you want to explore. So oftentimes I've noticed that academia is at a few steps ahead of where industry is, because industry is kind of constrained to make it feasible to solve a real world case. So it's usually like they're doing, say, so nowadays I don't know if you've noticed, but this recently OpenAI published this neural network called GPT-3, which uses 175 billion parameters. So and that's great. It's doing amazing things. For example, if you go on Twitter, it's a like there are people tweeting about the various kinds of things it's doing. It's doing philosophy. It's talking about like in a very human like fashion, and like it's making people like humanity reach a level where maybe we are one step closer to the Turing test, passing a robot passing the Turing test, which is the test
Wow.
when a robot is successfully able to fool another human being that into believing that it was not a robot and it was a human being talking. But then if you think about it, for an industry research industry to kind of catch up with that and actually use that in production, I believe it's going to be very hard for companies to do that. And but then that is another side of research which I'm sure both people in both academia and industry would be working on to make things more feasible and scalable, which is again the need of the hour.
But yeah, I mean, talking about catching up, like this is one of the favorite questions that I have for anyone I invite on this. And typically, it would be much more interesting to learn from you because
Mhm.
I guess your expertise would be NLP. Even like back when I started 2015, when I started the whole interest, like my interest in machine learning thing, NLP is definitely one of those domains who has like kind of accelerated a lot. I mean, in terms of new algorithmic interventions, or in terms of accuracies, or in general performances, like you said about the
Right.
GPT-3 thing. So, from your perspective, working at wherever you are, I mean, either it's CMU, Google, or anywhere over here, what was your methodology for keeping yourself updated to these latest developments? Because talking about algorithms is different, but when I actually ask of you to kind of implement that thing, a lot of factors other come in, like resource. Like, definitely implementation is a whole different level of knowledge, I guess, we engineers learn over the time. So what over the time, what was your best practice that you developed? I know that this could be really specific to your language of study. What was, how do you, like, is it research papers, is it conferences, blogs, or Twitter? What was your to do best practice for keeping yourself updated to
Sure.
latest developments?
Right. So, so yeah, that's a very subjective question, and different people have different preferences. Personally, what has worked out for me quite well is, for example, when I was doing research in during my masters and like for my course projects and also for my thesis, it was mostly focused around like reading papers that are specific to a particular topic. And oftentimes, what I would do is uh, first of all, it begins with a Google search where you talk about a topic and go to, say, Google Scholar and search for papers which are talking about it. Then you pick up the top few ones and see what kind of approaches people have used. Then one thing that has worked out well for me is going to the references part and seeing what papers are they referencing. Some of the most cited papers uh, in those papers is, again, it's like a reference to the next thing that you should read upon. So that's one thing of discovering knowledge when you are working on a set goal of a project. But in general, to keep yourself updated, I keep myself updated. I refer to some of the blogs on various websites, particularly Medium. It has also seen a tremendous amount of like upshot in a lot of blogs that are being written about machine learning and NLP specifically. So like so sometimes some of the authors, they have like good digests of what happened in a particular conference. If you're not able to attend the conference itself, you can, and it's a humongous task for everybody to kind of do it on for every conference to read every particular research paper. But what they can do is they can just to see the highlights and see what kind of papers, what the topics were, and which authors have published them, and then maybe what one or two topics that interest them, they can read that paper. Of course, if it becomes a very unmanageable task, something that a lot of people have recommended me that I've started doing is there are multiple ways to read a paper. One is a 2-minute way, one is a 10-minute way, one is a 1 hour way, and you can spend 2 days on a paper or maybe more than that. So 2 days is something I would spend on a paper when I'm actually trying to implement it or use it in my research. But if not, I would probably just do a 2-minute scan of it. And if it sounds interesting, I'll do a 1 hour read and start with the abstract conclusion and then see what kind of methods they use and kind of glimpse it all over through. So other than that, people often use Twitter for talking about their research, and it's of course both famous and infamous for arguments. So if you are trying to avoid negativity in your life, then it's not a very good choice. But otherwise, yeah, Twitter is also somewhere which is quite useful for getting to learn what people are doing. And most importantly, yeah, this is something I should have mentioned in the previous part as well, is talking to other students and researchers who are working in that domain, which is certainly different from in academia, because in academia, you're surrounded by people. For example, in Language Technology Institute, I was surrounded by people who were doing research on various kinds of problem in NLP, and not just the problem that so for example, now in Google, I'm mostly surrounded by people who are working on a very specific topic and not NLP in general. So I'll get to hear about things which are happening in my topic, but not, for example, if I'm not working on co-reference resolution, I may not get to hear about it very quickly. But being in an academic environment provides you that opportunity as well. There'll be professors talking about it. You talk to more people that way. So,
Yeah, that's one thing I actually can second that, because over the time I have realized, because there might be a solution out there on the internet that says that, hey, do this XYZ method, but a personal opinion from person who might have actually worked on that particular
right.
aspect might have a very different opinion, and you might not just believe it that way, because you might say that, hey, that Medium post says that, or the paper says that. But what we often miss out is there are much more dimensions to that problem, and only a person who might have worked in the past, who might not be
Correct.
able to justify why way to use that method, but still that method would be the best thing. So yeah, one thing that I'm kind of trying to absorb in is trying to learn from people. Like for example, something like a episode like this, like talking to you, it's definitely helpful to understand your perspective on it. So yeah, that's a very interesting thing. And actually talking about, like you mentioned about how you typically approach a research problem, like you give one minute, 2 minute thing or 2 day thing on a research problem. And one really interesting thing that I don't think I still have an answer to this, and when I can ask you is, as a person who tries to work on deep learning NLP domains at Google, like what is a typical day? Like how does, like it is like based on my experiences of working at companies, it's like they have sprints and all those things, but they are not like, I have never worked at a company who does typical research. So how does, like, just feel free to again
Sure.
omit the
Yeah.
information that is harmful for that, but like how does, like, is that a kind of a sprint thing? Like how do you work? Like are you I'm assuming you don't like you typically work with TensorFlow because it's Google. So like how does your normal day routine looks like on an average day?
Correct. Sure. So so it at Google, because it's a large company, and most such companies don't have a defined way of working, and it differs greatly across teams. So of course, and one more thing I should have mentioned in the beginning is whatever I'm saying is like my own thoughts, and
Yeah.
it's not general, and I'm not speaking for Google. So specifically, what I've seen my team doing is they don't follow any like agile software development principles, because we're not so much into development right now. We are mostly like exploring and doing experimentation and doing research to figure out what the best approaches might be. And if the approaches kind of seem to work, then we try to like productionize them and see what the differences are. So a typical day for me is very different through the week. But I would say, for example, a typical month from me, month is a more tangible cycle, which would cover most parts. So is that it, of course, begins with like doing some related work survey. And of course, when you are in industry, in working in a company, so there is a lot more resources that are available on the internal companies pages. And like if you can reach out to people who have worked on similar projects for different products of the same company. For example, if I'm working on Google search, something might have been implemented by, say, Gmail. So I can reach out to that team and learn more about what they did and what worked out well for them. So, and because each product is definitely trying to be on the frontier of their domain, so it's very likely that whatever is working out well in the research nowadays is something that is a shared problem for all of the products across Google, like not all, but many of the products across Google. And once you kind of figure out an approach, then you try to like do some kind of exploratory analysis in by looking at what kind of things are there in place currently, and what improvements can you make, and are they feasible or not. And because I'm a relatively new person in the team, and there have been people who have been working on these products for like more than 15 years, and so I definitely consult them for their opinion. This would be something very similar to, say, talking to the professor about the approaches that you thought about, and they give you their opinion as to what they think it might work, it might not work, or is it something that a similar thing that they've tried out in the past which did not work or something. Then when you begin working on it, it's mostly IPython notebooks. We use it on Google Collaboratory, which is a hosted IPython notebook that runs on Google Cloud. So, and Google Cloud also allows you to use TPUs, so that is a plus point as well. But to use Google Colab. The coding basically begins on that. One important thing which I've missed is like writing a design documentation of like what you are planning to do and what your deliverables would be. So for example, if I'm trying to increase the, say, accuracy of a particular task by, say, 0.8% or something, so I need to like justify why I think so and what my hypothesis is and what kind of data I'm going to use. There are sometimes data disclosure, some disclosures involved where I have to like get approvals from the relevant teams to use a particular kind of data. And there is a separate team which like takes care of like anonymizing the data and giving me aggregated data, so I cannot look at any user's data per se, but general aggregated data, whichever is allowed by the laws of the respective user and the country that we're operating in. Once we get hands on the data and we have a collab notebook fired up, we realize that, okay, the data is needs to be processed in a few forms to kind of be utilized. So at Google, we use something which is an advanced version of MapReduce, a streaming version of MapReduce, which people use to kind of like process large amounts of data in a faster time. So we use such tools to kind of write jobs which will transform our data from this format to another format which we need, or say it would involve, say, deduplication, some cleaning and stuff as well. Uh, Although not usually we don't try experimenting with newer data, and we sometimes just use the data that we have to kind of see what happens in experimentation. And when we try to like productionize things is when we use the latest data and the biggest amount of data that we can use. Then once we have the data, we kind of go ahead and train whatever models we have. And then I think some part I cannot talk about. And then eventually let's jump to the part where you have everything ready, and now you're trying to like productionize things. So you have to, again, before that, you have to get some approvals, which basically requires you to like make sure that your model is doing the right thing, and you have to defend why it's doing the right thing, and it will always continue to do so, which becomes a very challenging task in industries, because explainability is something which is the weak arm of neural networks. It's by explainability, I mean two things. One is, so actually it's basically the single thing that why is it particularly classifying something as class A? Like, why is it not class B? This is something that's not sometimes very apparent. And what would happen if I give it a different input in a slightly different manner? Will it change? This is something which I've seen in the past as well. For example, if you try to train a neural network which is trying to predict, trying to basically classify whether a particular image of a road has a car or not. Now, all of my pictures in the training data that I use are of cars which are in the city. Okay, and all the photos which don't have any car in them are, say, set in a field. Okay, so it happened one time where I read this somewhere on the internet. I think it was some paper that somebody was talking about where they found such things. Is that they trained the neural network to classify whether or not a car was present in the picture. But what the neural network actually was doing is trying to predict whether or not there were buildings in the picture, because all the pictures that had cars in them also had buildings in them. So it was not looking at the car, it was looking at the buildings to make the prediction. And the testing accuracy was wonderful, because in the test data also they had very similar images which had cars in front of buildings, and pictures with no cars would be in fields. So you don't know after training just that on that particular data set how it will perform on unseen data sets. And if you try to like change the image in a particular kind of manner, for example, if you make the image grayscale, or do some kind of like modifications with that, or if you try to like show a picture of a picture or something of that sort, so what would happen? So these are a few things that you have to keep in mind when you're working in industry, because there are often huge costs involved with going wrong. So you may not want to like bring down an entire product or make things very bad. That is one aspect. The other aspect is making things ethical. So it could not, you have to make sure that you're, because it's AI and it's not a human doing it, it may learn very ethically incorrect things. It may start suggesting things which are not related to that user, but often reveal information about another user. For example, if you're typing on, say, your phone, and there is an auto suggest feature. Now imagine if it could, instead of like suggesting you generic words, it starts suggesting you something that your roommate was talking about to someone. And because they use the training data together, and like there is some interchange involved, and it starts suggesting you things which make it very apparent to you that it belongs to your roommate, and, or like some other person in the world, very specific to that single person. So that's something that we would not want the model to ever do. But this is often ensured in the previous phase, where we kind of like bifurcate the training data and aggregate it in such a fashion that it's not doing that. Then, of course, there is this question of like latency, of how much latency will add to the whole pipeline. So basically, yeah, to like in a nutshell, it'll be a lot of like defending why it will work and why it will not work. You have to do a lot of experiments, see if it works, and then you kind of try to productionize it and launch it. So this is how a general life cycle look like. We don't have direct sprint calls or agile methods so much, because development is like a very it's one of the parts of the whole pipeline, but not the only part of the pipeline. So yeah, we do have regular meetings and stuff like that, which we brief each other on what things we've explored and stuff.
Right. Yeah, definitely. I mean, I agree to the interpretability part a lot because a very recent conference in this week I was attending by the Microsoft Research Frontiers in Machine Learning, and
Mm-hmm.
the person who is leading the whole project on interpretability, Dr. Rich Karuan, I don't know if I'm pronouncing his last name correctly. He also mentioned a very similar thing, because I can recall from what you said is he was actually implementing a neural network model. This is few years back, I guess 1995 or something, and he was implementing a neural network for healthcare sector, where the idea was to understand the biomarkers for pneumonia. And what the neural network gave it as a rule was person who have asthma will not have pneumonia. And doctors were shocked to see
Right.
the results because the accuracies were great. I mean, but doctor
Yeah.
said this rule doesn't make sense from a biological perspective. There is no correlation. Instead, people who have asthma would have a lower immunity to pneumonia. But the data didn't lie and the model didn't lie, but they were not able to explain. And what it turned out was at the end was that people who have asthma, they go through certain medications at an early age. And so they have those medications that are being treated over the time. And that helps you being prone to pneumonia, but there is no in way knowledge to understand that asthma is related to pneumonia. But so the idea, like the idea to catch for us as a computer science engineer was neural network might be smart. It might see things that don't make sense, but they do in a way in their perspective. So like the example that you mentioned, it saw buildings, but it's important for us to understand that, hey, you don't need to see the buildings. It was the car that I was trying to make you learn. So yeah, interpretability is something, I mean, it's a part of my thesis. So even I try to stumble on those things a lot. And the beauty and the challenging part is it's not structured. There is no formal definition that even the industry or research has come up with yet to understanding how to define interpretability. So I guess hopefully that.
But that's a hotly researched topic now as well, and many people have like been like successful to a limited extent also. There was this paper that I referred like some time back, which was talking about generating a natural language explanation to from the neural network itself while making the prediction. So it generates an output, but also generates a justification in the side, which talks about why it classified a particular thing that way. So yeah, it's like it's still being researched, but we've also come a long way, and there is still a long way for us to like go in terms of explainability.
But yeah, I guess this question might be redundant, but I mean, I typically ask this question at the very end of this episode is like, uh, just like kind of, I mean, we did talk about explainability, which is something that is the next few years people might be focusing on. But from your perspective, where do you see like, or maybe your interests, where do you see those interests growing? What is the next step you think
Mm-hmm.
the field is going towards, at least? Because one thing that I can definitely now say is computer vision and NLP are great domains, but it's only the people who work in those domains can predict. Because I literally cannot say anything about NLP because I have
Mm-hmm.
never worked on those things. So where do you see this field progressing? Like if I'm a person that is just like putting my hands on into machine learning right now in 2020,
Mm-hmm.
the field changes very rapidly. I mean, every week we open up and there are new things being developed. Where should my next focus should be? Like how should I plan my study, like understanding, okay, should I learn about transformers? Should I also understand rule based NLP, like, because that is also a definite base people need to clear on. Like where do you see this whole field, if you were to summarize
Mm-hmm.
from
Yeah.
2013 to 2020, like what would you say, where's the field heading according to you?
Sure. So yeah, one thing that we've all seen that in the past decade is that it has evolved, like it has moved from rules based or like finite algorithm based natural language processing to like now more machine learning and more deep learning oriented things. One thing that I have a bias towards, because I took a course on deep reinforcement learning, is that, so deep reinforcement learning is the branch of machine learning where you basically like give an agent a reward if it does the right thing, and you give a penalty or like no reward when it does the wrong thing. So, and that's how you kind of like teach a reinforcement learning agent, just like you would train a baby. Now, this field has been particularly been applied in a lot of robotics and a lot of image-based applications. But recently, I've noticed that it's being applied to a lot of natural language processing tasks as well. For example, to do summarization. So this is something I worked on during my masters as well, where we were using reinforcement learning to give a feedback to the neural network that, okay, you did a good summarization or you did a bad summarization. So it'll try to learn overall to like increase the reward and like do good summarization. I feel it's still at a very nascent stage, and there is a long way to like leverage reinforcement learning and the newer algorithms for NLP. So that's definitely one thing I see coming in the coming years. Another thing is like explainability is definitely a hot topic which is being researched, but we already talked about that. Other than that, yeah, there is this emerging field of meta learning, which is learning about learning. So where you talk about making like transfer learning tasks simpler. For example, if you know how to say identify cats in a picture, can you use that knowledge to identify tigers in a picture? So tigers are going to be slightly different, and you don't want to be misclassifying cats as tigers. But can you, given that you've already trained the neural network to like classify a cat correctly, can you go to this? So this is generally called transfer learning. Now within transfer learning, if you want to do it in a few short, that is basically using a few new examples. You need to know what you've learned, and it's the learning about the learning that the neural network has done. This is something that humans are very good at. If I teach a kid how to like classify cats and tell them how a tiger differs from a cat, they can probably like identify a tiger with very good accuracy as well. So this is also something that I see happening in the coming years. Another thing is I feel Markovian and graphical models is something that people have used in the past, and I've recently started seeing some work on other kinds of like architectures like Markovian models, HMMs, and other kinds of probabilistic graphical models, which people have been using, and I don't think they've been tapped a lot into natural language processing tasks. Same goes for Bayesian learning as well. Um, yeah, and recently, because of many of the recent events, and it's not a very new thing to see, but sometimes these models are very biased towards a particular community, or say they are sexist, sometimes they are racist, sometimes, and they are very biased towards the training data, and sometimes it causes problems. For example, if this one paper that was talking about a particular thing is that when you like search for images of a doctor, you wouldn't want to see only male doctors, but when you search for you would see only male doctors sometimes, and when you search for, say, nurses, you would typically see female doctors. But that is not something that people would want to propagate through AI. So like debiasing these neural networks so that they can like present a good balance and not do things like this is also something that's very important, I feel.
Right. Yeah, yeah, definitely. I can definitely agree to this. I mean, there are a lot of problems, all those like biases in data sets versus learning, like bias in learning. And all of these
Yes.
I can see bottlenecked over the whole idea of explainability. I mean, if we solve explainability, maybe we can just kind of address these
Right.
issues. And yeah, definitely. One thing I can definitely agree on your prior point was definitely I attended the CVPR conference in 2019, and where Jitendra Malik said these things like the next big thing we should be seeing is an amalgamation of these domains like NLP and computer vision working together to solving problems, and it will involve typically these learning techniques to be inspired from like I mean I this might be thinking out too loud as
Mhm.
like how BERT actually trains and how it uses its learning methods versus how CNN does is completely different. But maybe an inspiration technique from all of these learning methodologies might be a
Sure.
new factor. And yeah, meta learning, one shot learning, transfer learning, active learning are all these new techniques one needs to explore. But yeah, definitely agree. And one last question that I will have, and this is specifically for the people who are like kind of new to the whole domain, who for all those people who research is something at a n+1 stage, but at the nth stage. Uh, so even one thing that I've realized, and I'm sure you might have realized, is understanding a concept versus implementation is something really critical. I mean, you cannot just have both things being done at the same time. I mean, understanding an algorithm is a different task, but also implementation is something we learn over the time. So how do you think people should approach this thing? So one of the things that a lot of people in the previous episodes have also said is hands-on implementation. There is no shortcut to learning how to do these things. But over the time, what do you think was kind of a helpful factor for you to implement? Was it internships? Was it course projects? Was it Kaggle? Or like in general, were you like, what was your like what was your solution to solving the problem of implementation, so that you make sure that if somebody tells me to implement a ResNet model, I won't be shocked that, hey, how do I do that,
Mhm.
versus in PyTorch or TensorFlow or any framework using? How did you
Right.
approach this problem?
So I think what I've done in the past, and I usually like apply it to like usual like problems that I face, is like first I try to like see the overall picture by seeing like using say the code that is published along with the paper or something that helps me like make the overall pipeline and see what goes as input and what comes out as the output, and like how to make the overall get the overall big picture of it. Once you know that, what you can probably do, there are two ways. If you have the code available from the published paper, you can definitely read up through it and like see what kind of things they have implemented and like kind of build upon it, whatever your changes are going to be. Or you can like try to start doing things ground up. But for starting to do things ground up, you need to have a very strong understanding of like the libraries that you're going to use. For particularly in deep learning, it's going to be either TensorFlow or sometimes we will use PyTorch, or whatever their choice or their library of preferences. So and between PyTorch and TensorFlow, like they have a very different angle of understanding of like expressing things. So the PyTorch way of doing it could be significantly different from the others. So like you like have to be mindful about it, those differences as well. But yeah, definitely looking up their documentation for like functions that you can use, and looking at the default arguments that they have sometimes plays a very important role. One thing I've seen while implementation is that many a times there are default parameters which are setting things differently, which I did not want to set, which I did not want to even set. And these are certain kinds of bugs which are sometimes very hard to figure out because, for example, if there is this particular parameter, some constant in a network that you, in a particular layer that you have, and your library is automatically setting it to a default value. You didn't want to do that initially, but you don't have it in your code either because that's a default value. So it's very hard to figure out that, okay, it's because of a default value. So like if you have the documentation handling, even for the functions that you think you are fully familiar with, is a useful thing when you're trying to like build things ground up and write code for it. One thing that I found useful is like organizing your code well enough. So like have a proper directory structure. One place you have to like define a README, and like that README is not just for other people to like read your code. It's also for yourself to kind of stay honest and know what your primary objective is. It's where you like define your constants that, okay, I am trying to do this, this, and this. So whenever you are implementing, you can always refer back to your README and see that, okay, this was my objective and this is how I plan to do it. So this like to resolve any confusion or any decisions that you have to take. And like it is often helpful to write tests if you are building especially if you're building something like which will have a lot of lines of code. So writing tests could be useful as well. However, I do like, while it is a very good idea, I don't think I've done it for like very small things sometimes. uh, but yeah, keeping separate models in separate files and then like having a main function, the pseudo main function that Python has or whatever your language of preference has, is useful to kind of invoke them and have the code in a very organized manner, It also helps when you kind of like try to like publish some paper around it, or like present that code to someone else, and they can of course get onboarded very easily when they know things where they want to work on. And one more thing is like specifying arguments. So because neural networks, by the virtue of it, they need a lot of hyperparameter tuning. And now we've come very far from where we were like a few years ago in terms of like hyperparameter tuning. But there is still a slight lack of direction when it comes to tuning those hyperparameters and specific changing them. So you have to train your model sometimes again and again to see what set of hyperparameters work well for you. So it might be useful to kind of specify a configuration file that you read into from your like function when you use your models, and parameterize everything that you can. Don't have magic numbers in your code which are just specifying things within the code at various places. Have a separate configuration file, and whenever you have to refer to say the number of neurons in each layer, or like the number of recurrent layers that you need to have, or whatever be that parameter or the learning rate, like it could be specified in a separate text configuration file. There are a lot of like libraries which help you read through configuration files, arguments, and so on and so forth. So you don't need to worry too much about like reading them. It's not a big deal. It's like probably just a single line of code that will help you read it and make your life significantly easier if you can do that.
Yeah, definitely. I can definitely see those best practices really helpful, because at least one I can definitely say is even I'm not able to read my code few months back. So definitely
Mhm.
I should probably even I'll just document and comment out the code just for myself. I mean, I can just imagine how the pain
Right.
if somebody else would be reading my code. So I definitely agree on that. But
Mhm.
yeah, these are really nice insights onto these things. And yeah, I mean, I don't have any other question specific, but just like maybe like, do you have any kind of just kind of an overall advice for any people who are starting? Like typically, I have seen the most of the people who are watching this videos are like kind of an undergrads in their respective domains. Like, would you
Mhm.
have any kind of just in general, like just a piece of advice for them, like
Sure.
just kind of a do's or don'ts? Like, what do you think about the whole
Mhm.
computer science thing and how
Yeah.
people should approach?
Yeah, it's a like so it's something of a lot of responsibility to give a generic advice, but I can mention a few things that have worked well for me and have not worked well for me. Is like I've seen like when you fixate on a particular problem and then try to scope it out into very tangible deliverables, even if it's a research problem or if it's an industry problem, it doesn't matter. If you can like figure out very specific deliverables and milestones for it, so and have a very clear understanding of what you have to achieve in a particular phase, that's going to be that has been very helpful for me, uh, rather than having a general idea of okay, I'm trying to do co-reference resolution or say sentence simplification. Now that is still a very vague topic. Now you have to define exactly what data set you are going to use, what objectives you are trying to meet, what is going to be your evaluation metric, what kind of an improvement are you looking for. If you're trying to publish, what conferences are you targeting? Are you targeting something that's close, like that's already close? So like what kind of schedule should you have? What if something goes down and like you're not able to finish things in time? Do you have any backup for that? Or would you need any collaborations? Do you need inputs from somebody? So like listing down those things and having a document handy, tracking the progress of your project is something that's useful. And uh, I can agree with to the fact I've seen it myself that sometimes an undergrad people are not very sure as to what field they want to pursue very well, and they're mostly looking to like do something, and that something is like a question mark, and they like we have to like figure out that okay, I'm ready to work on any problem, just give me any problem and I'll figure out something. That is a perfectly okay approach and there is nothing wrong with that. But as soon as you try to like realize that okay, that is your domain of interest, fixate the problem that you want to solve, and then like find resources that will help you solve the problem, rather than finding the resources that you have and then using them to solve any pick any problem. I think that's something that has worked well for me.
Yeah, definitely. That's a fair enough advice. I mean, definitely I can see that advice really helpful to me too personally. So I can definitely say for all the people seeing this video. But yeah, that's all I had for this podcast, and I'm really thankful to you. I'm sorry for
Mhm.
hogging up your weekend for this thing.
Oh,
So
absolutely no problem.
and thanks a lot. I hope people would find this video helpful, and definitely I'll make sure to maybe I don't know if that would be fine. I'll just link your LinkedIn thing so that if people have some valid enough questions, they can reach out to you. And
Sure.
definitely, yeah, people can post questions, and I'll make sure those questions are answered. But
Sure.
yeah, bottom of all, thanks
Mhm.
a lot for doing this,
It was
and
really my pleasure.
yeah, see you soon.